We are going to talk about a new topic, hypothesis testing. And so we have to recognize this is, in some ways it's going to feel like the confidence intervals, but it's different. It's a different approach. And so it's actually called a test. And you have to create a hypothesis. And so hypothesis testing, you propose a statement, or someone does, you make a claim sometimes, that about a population parameter. Usually it's mean or a proportion. So you have to decide on these what you're working with, means or proportions. And then we have to collect data and test to see if something is true or not. We're testing to see if the statement is true or not. And so you, here's an example right here. What it's saying is, you work for a campaign and the polls from the previous election had your candidate at 55%. So this is the old data. So you saw this 55%, but you're not sure where it stands now. And so you're wondering, is it below 55%? Because if so, then you need to run some ads, okay? So this is going to affect your actions. And so you need to find out, have things changed? So you decide you're going to do a hypothesis test to find out if support is less than 55%. So this is key information. Hey, is support less than 55%? We need to know, because it used to be 55%. If it's less, we need to do something about it. So we always have to have two statements. So every hypothesis starts with two statements. So we want to say the null hypothesis, meaning this is what we are going to assume that this is true, that it is at 55%. But what we really want to know is it less than 55, less than 55%? So we have this alternative hypothesis, HA, okay? So this is sometimes called HO, and this is HA, okay? So null, meaning zero, or alternative, that it's less than that. Now the thing is, let's skip down here, what we're trying to prove is our HA. So HA is what we're trying to prove. We're trying to say, oh, hey, we think it's less. So it could be just not equal. We could be wondering, has it changed? We would say not equal. But in this case, we want to know if it's less than. So the problem's going to tell you in some kind of language, greater than, less than, has it increased, has it decreased, or simply has it changed, okay? So has it changed, or is it different? So if we just want to say, have things changed, we would be using not equal for our HA, okay? The nice thing is really, is that for our null hypothesis, it's always equals. So that's kind of always going to be true. You're always going to use an equal sign for your null hypothesis. And we usually list the null hypothesis first and the alternative second. Okay, so P here is our true population proportion of people who are going to support your candidate. So you want to define, okay, you want to make a definition of what this is. What is P? Okay, so you're saying it in words. It's the true population proportion, okay? These are parameters of people who support your candidate. Notice we don't have a P hat there. Okay, so that's what we're wondering. What's happening with the true population of voters? Okay. So this is kind of interesting. So we always assume that that's true, and then our goal, assume it's true, but we're trying to reject it. So we're trying to say, hey, it's not that. It is actually less. Okay, so that's kind of our orientation here in our thinking. Assuming this is true, but seeing if we can reject it. Okay, so it works in these three simple steps. You assume it's true. So you say it's equal. That's the null hypothesis, like our starting ground. You do some calculations to see if there is enough evidence to reject the null hypothesis. Is there enough evidence to reject the null hypothesis? Because we're never going to accept it. We're never going to say it's true. What we do is we just simply say, can we reject it or can we not reject it? And the actual, you guys asked me about magic phrases. These are these kinds of magic phrases. The actual language here is that you either reject it or you fail to reject it. That's it. That's the language you use. Reject or fail to reject. You never say you're going to accept it. Okay, never, never, never. Okay, it's reject or fail to reject. So that word reject and the null hypothesis has to be in your response. It's either reject it or fail to reject. Okay. And so, yes, this is a weird fact. We can never actually prove that this is true, and mainly because we really are working with probabilities. The area under the curve is sort of like an area that is related to the normal curve and the probability of being between some values. So we are either above the value, below the value, or between two values, but we never really say we're at a value. Isn't that interesting? Because basically if it's area and you're at a value, if there's no interval, then like if you're thinking of the area of a rectangle, right, and you're talking about a number on a number line, you're saying x bar or something, you need to go between two values. You need to go between x1 and x2 to really calculate an area. And so because that rectangle has to have two sides. But if you only are looking at the mean, then it's a point. There's no side. There's no area. It's very interesting. Okay. So again, look, it's here again. That's how important this is. Reject or fail to reject the null hypothesis. Okay. So let's do a little examples here of how you would set this up. So these are examples. Notice our null hypothesis. Here's an example of not equal. Here's an example of less than. Here's an example of greater than. Notice we have mu here, population, true population mean, the true population mean, or the true population proportion, okay? So we're using mu and p. You have to decide from the problem whether you're doing means or proportions, all right? And then you have to decide what is the equality or inequality on my null hypothesis. Okay, we're growing tomatoes. They must be exactly the correct height. If the mean height of a batch isn't 5 centimeters, then we need to send the whole batch back. So we're doing a hypothesis test. What would it be? So in this case, our null hypothesis, assume they're all 5 inches or 5 centimeters. Assume they're 5 centimeters. So let's just say they are. What we're wondering is, can we prove that that's not true? So can we make this alternative that they're not equal to 5? So notice in this problem, it just said isn't 5 centimeters. So that's what we're trying to determine here. Also, in this next problem here, you don't think your showers take that long, but your mom disagrees. She claims you're taking showers for 20 minutes, and you're saying, no, I'm not. I'm sure it's less than that. So let's assume that her statement is true, and that your average shower time is 20 minutes. That's your null hypothesis. Average is 20. Notice this is a mean, right? We're measuring the time, right? Anything you can measure, guys, remember measuring. When you're measuring, you're going with a mean, usually. But if you're counting, like how many, right? Then you're dealing with a proportion. Okay, so measuring the length of the shower, you're saying it's less. Create a null and alternative hypothesis. Null hypothesis is that she's right. It's 20 minutes. That's the average. Alternative is, and you're trying to prove her wrong, it's less than that. Okay. Can your mom really prove the mean is exactly 20 minutes? No, but you could prove your case. You could also fail to prove your case. So you're going to prove it or fail to prove your case, all right? So we're not proving that it's 20. We sort of assume it, and then we're trying to argue against it. Okay. Last example, a university has to decide to introduce the use of plus or minus letter grades, like instead of just B's and A's, B plus, B minus, A minus, that kind of thing. So as long as there's evidence that more than 60%, that's our more than right there, of the faculty, but this actual point estimate of 60%, we're saying more, we're going to assume it is equal to 0.6, it is 60%. So remember that proportion is always written as a decimal. So we're going to assume the proportion is 60%. And then what we really want to do is say, no, we want it to be more than that. And so we're trying to go with more than that. The resulting data will be used to test the relevant hypotheses. Create a pair of hypotheses that the administration should test. So again, defining P, okay? So always define mu. Say what it is. Say what you're trying to figure out. It's a lot. This is a lot of new notation, new information. Sometimes it's a little confusing on how to choose. But whatever is being said in here, whatever that cutoff value is, that's your null. That's your null. Whatever that number is, 5, that's your null, equals 5. 20 equals 20. 60% equals 0.6. And then from the language of the problem, you decide whether you want it to not equal it, be greater or less, versus just less or just greater than. Okay, that's it for 10-1.